Hi everyone. So today we will discuss the Further Pure Mathematics paper 3 F3 January 2022 paper. Let's start with question number 1. Use the definitions of hyperbolic functions in terms of exponentials to prove that 8 cos to the power 4x is equal to cos 4x plus p times cos 2x plus q, where p and q are constants to be determined. Okay, 3 marks. Okay, so let's write the definitions of the hyperbolic functions for cos x. So let's use the definition of cos x. So what's the definition of the hyperbolic definition of cos x? E to the power x plus e to the power minus x divided by 2, right? Okay, so we are supposed to get the expansion of 8 cos to the power 4x. Basically, it's 8 times cos x to the power 4 is cos x is ex plus e minus x over 2, right? So this whole thing to the power 4. Are you with me? Okay, let's get it done. 8 times, so I can take the power 4 for the 2. 2 to the power 4 gives me 16. Shall I take the 16 out like this? 8 over 16 ex plus e to the power minus x holding to the power of 4. So basically to expand, power 4 means you write the same bracket 4 times, or we could basically go for a binomial expansion. That is a lot easier. 8 over 16 is half. Shall we go for a binomial expansion? So what happens here? 4c 0. We can give ex a power of 0. One number gets the power of 0. Other number gets the power of 4. E minus x gets the power 4. Are you with me? Let's quickly expand. Plus 4c1. Next, ex gets the power 1. E minus x gets the power 4 minus 1, which is 3. Next one is 4c2. Ex gets the power 2. And e minus x gets the power 4 minus 2, which is 2. Next one, 4c3. Ex gets the power 3. E minus x gets the power 4 minus 3, 1. And the last term, 4c4. Ex to the power 4. E minus x to the power 4 minus 4 is 0. So basically this is it. Okay, let's simplify. Can I know the answer of 4c0? 4c0 is 1. Ex to the power 0 is also 1. E minus x to the power 4 is e to the power minus 4x. 4c1 is 4. This is ex into e minus x to the power 3 is e to the power minus 3x. Do you agree with me? I just wrote the answer for this term. Do you agree with me? The next one, how much is 4c2? 4c2 is 6. Ex to the power 2 is e. 2x, e minus x to the power 2 is e minus 2x. Do you agree with my answer? And the next one, 4c3 is 4. Ex to the power 3 is e to the power 3x. E minus x to the power 1 is e minus x. Agreed? That's this term. And then the last one, 4c4 is 1. E minus x power 0 is also 1. We get here what? E to the power 4x. Are you guys with me? So when I simplify, I get here e to the power minus 4x. And then let's take the like terms here. I think these two, e minus 4x and e4x, I'll bring them close to each other. And then here I get 4ex, e minus 2x gives me 4 e to the power minus 2x. And then the red color term, 4e3x, e minus x is 4e to the power 2x. And the last term, 6e minus 2x, e2x gives me 6e to the power 0, which is basically 6. So I get here half times. So we need to now get cos 4x and cos 2x, right? Yeah. So then what is cos 4x? Cos x is ex plus e minus x over 2. So cos 4x is e4x plus e minus 4x over 2, right? And I think we already have it, right? So I think you can see here, let me input the half inside. So e minus 4x plus e4x, I'll take it with the half. Is that okay? The half also goes for the other terms. I'll take 4 out here. E minus 2x plus e to the power 2x. Shall I put the half inside? I took the 4 out of them and I put this half inside with these two because the half is common to everyone. plus half into 6 is 3. Do you agree? So I want to keep this half here. I will not cut the 4 and 2 here because I want this half over here. So half e to the power minus 4x into e4x is, this is cos 4x. Then here the 4 and basically this part, this is cos 2x, right? And what cos 2x? 4 cos 2x, and then plus 3. Okay, so this is the answer. And then the P and Q values are 4 and 3. Is this clear? Okay, then we'll move to the next part. They say hence or otherwise. Basically, hence, going with hence is easier. Hence means using the help of the above part. Solve the equation cos 4x minus 17 cos 2x plus 9 equals 0, giving your answers in exact simplified form in terms of natural logarithms. Okay, so they ask you to use the help of the previous part and they're asking you to solve this equation. Okay, so part B, what was the equation again? Cos 4x minus 17 cos 2x and plus 9 equals 0, right? Okay. So now thinking about what we have proved earlier, can you all tell me how I can use the help of the previous part to get the answer here? Okay, so to get the answer for cos, to solve this particular equation, what we do is, you can see we have cos 4x here. So using, they have said the word hence, thereby using the equation which we proved in part A, we can use we can get a substitution for cos 4x. Do you agree with me? So who is cos 4x? If you use cos 4x, it's 8 cos to the power 4x minus 4 cos 2x minus 3, right? 8 cos to the power 4x minus 4 cos 2x minus 3. That's the replacement of cos 4x. I took these two to the other side. Okay, that's written in green. And then continue the remaining part. What's the remaining part? Minus 17 cos 2x plus 9 equals 0. Okay, and then what do we get here? 8 cos to the power 4x minus 4 cos 2x minus 17 cos 2x is minus 21 cos 2x minus 3 plus 9 is plus 6 equals 0. Okay, and then we come to this equation, but in here again it's cos, here you have a single x, here you have a 2x, so that also doesn't work. How do we make it into a single x? Cos 2x needs to be replaced again, right? So what's the replacement? The double angle rule of cos 2x. What's the double angle rule of cos 2x? Cos 2x is 2 cos square x minus 1. It's quite identical to the trigonometric equation, right? Because we have a product of a cos, it doesn't change. There's no sign change. When you have a product of sign, only the minus, the plus mark becomes minus by using Osborne's rule. But here we have a product of cos, so there's no problem. And I get here plus 6 equals 0. So 8 cos to the power 4x minus 21 into 2 is minus 42 cos square x. Minus 21 into minus 1 is plus 21, plus 6 is plus 27 equals 0. Do you agree with me? Right, so I come to this equation. Okay, now this is a equation where I have only cos and it's cos x. So there are multiples of cos x. So this is basically like 8y to the power 4 minus 42y to the power 2 plus 27. Okay, so this can be factorized. We can take it like a quadratic equation. You could, since you are doing now further maths, you don't really need to use any kind of substitution. Basically y is the cos square x. So y square is the cos to the power 4x. I don't want to do that since we are now doing further Pure 3. Can you all immediately tell me the two factors here? Does it factorize well? Yes, what are the two factors? So basically here the x is the cos square x, the basic unit. Okay, when you type ABC in the cal, 8 minus 41 plus 27, what do you get in the calculator for ABC? No, you get x equals what in the cal? 9 over 2, x equal 9, but you know now x in this case is cos x. So we get here what? 2 cos x minus 9, right? 2 cos x minus 9, and the other bracket is, yeah, 3 over 4. 3 over 4 means it's going to be 4 cos x minus 3. Do you agree with me? Equals to 0. And then let's make each bracket equal to 0 separately. 2 cos x minus 9 equals 0. or 4 cos x, sorry, cos square x. Yeah. Basic unit is not cos x, cos square x, because this is the basic unit. Yeah. So 2 cos square x minus 9 equals 0, or 4 cos square x minus 3 equals 0. Okay, simplify, make cos x a subject in each of these. So then I get here cos square x equals, what's the answer? 9/2, which gives me cos x is root 9/2. By the way, in cos x, do I need to use plus or minus? So for this, you need to now, normally when you put the root, we put plus or minus, right? But you need to remember some properties about the cos graph. Okay, so what are the properties in the cos graph? If you remember the shape of the cos graph, you know certain answers that are not possible. If you remember, cos graph goes something like this. The minimum point is at 1. So basically, we can never get a negative answer. Thereby, I can only work with the positive root here. And cos graph is also definitely above 1. Okay. The other graph I get here, cos square x equals 3/4, right? Which means cos x is root 3/4. By the way, root 3/4, is it an answer more than 1 or less than 1? It's less than 1. So do you think I get solutions for cos x equal root 3/4? No, there are no solutions because the graph never reaches that point. But to have solutions for cos x graph, it needs to be 1 or more than 1, the y value. Okay, so I only have one answer here for cos x equals root 9/2. So now get x equals what? R cos, right? So x equals R cos. X equals R cos root 9/2. Root 9/2. Okay, input the value. What's the equation for R cos x? R cos x is equal to, it's given in your formula book, right? Ln x plus root x square minus 1. Yeah, this is given in your formula book as well. So replace the x with, now what? We are going to replace the x with root 9/2, because R cos root 9/2. So R cos, the x value is root 9/2. Replace ln root 9/2 plus root 9/2 gets squared. Okay, so that's 9/2 minus 1. So when we simplify, x equal ln root 9/2 is actually 3/√2, right? Plus 9/2 minus 1 is 7/2. So this can be, have they asked us to simplify? What format do they want? I'll give you an answer in exact simplified form in terms of natural logarithms. Yeah. Okay, so get the answer here. Actually, in this, yeah. So then what do we get here? 3/2/2 is a simplified rationalized form. Root 7/2 in the calc gives you root 14/2. Yeah, so this can be a final answer. Okay, is this okay? Okay, moving on to question number 2. Let's say figure 1 shows a sketch of the curve C with parametric equation x equal ln sec theta plus tan theta minus sin theta, y equal cos theta. The curve C is rotated through 2 pi radian about the x-axis and is used to form a solid of revolution S. Using calculus, show that the total surface area of S is given by this particular equation, and it's 8 marks. Can you see? So basically, they are rotating this 2 pi radian around the x-axis, right? And you get something like this. You see the 3D object. So they are not asking you for the volume of it. For volume of it is you learn in P3, P4, right? P4. Now they are asking you to calculate the total surface area of this object. So get the total surface area. There is a special formula, right? You have learned of this formula. Give me the formula quickly. Okay, so then how do we get the total surface area? There are 2 equations here. One, these are already provided in your formula book. So surface area equal 2 pi integration y times 1 plus dy by dx square, the whole thing root. And actually you can see here, this is the Cartesian form. Okay, and the other one is the parametric form. In your formula book, they have given you this equation in terms of t. So basically, I will use the same equation. Instead of using the letter t, we use theta here. Our parameter is theta. You can see basically here your x and y are clearly separated. So it's parametric, right? So use the parametric equation and your limits, the theta parameter limits are from 0 to pi over 4. Are you with me? So we need to find dx by d theta and we have to find dy by d theta. So what is dx by d theta? X equals ln sec theta plus tan theta minus sin theta. So when you differentiate, dx by d theta equals ln differentiation is 1 over, right? 1 over sec theta plus tan theta. Then into sec differentiation, you have to multiply with differentiation, right? Sec differentiation is sec theta tan theta, right? Check the differentiation. Do you need me to bring up the rules? Sec differentiation is sec tan plus tan differentiation is sec square. Minus sin differentiation is okay. So then can you all simplify this? So what do we get here? 1 over sec theta plus tan theta take the sec theta out and we get here tan theta again plus sec theta. Do you agree with me? Basically, I can cancel out the sec theta plus tan theta. Do you agree? Right, we can simplify this and then I get here dx by d theta is what? Sec theta minus cos theta. Right, sec theta minus cos theta. So we'll leave it at that and then get the differentiation of dy by d theta also. So y equal cos theta dy by d theta, cos differentiation is minus sine. Okay, so then shall we input the values into the equation? Surface area equal 2 pi times integration y is cos theta, right? I'm replacing the y value here. Y is cos theta times root dx by d theta square is sec theta minus cos theta whole thing square. Dy by d theta is minus sin theta whole thing square. Okay. 0 to pi over 4 are your limits. And then zero to pi over 4 cos theta. Open the bracket, what do we get here? Sec square theta. Sec theta minus cos theta square means we get minus 2 sec theta cos theta and then plus cos square theta. And then plus minus sin square is plus sin square theta d theta. What do we get here? Root cos square plus sin square actually can give you 1, right? Yeah, this gives you 1. Sec theta is 1 over cos. Basically, these two cancel. Sec is 1 over cos, into cos will cancel. So you end up getting here what? Sec square theta minus 2 and then there's another plus 1 that comes from cos square plus sin square is 1. So inside the root, what do I get? So I get sec square theta minus 1. Sec square theta minus 1 is tan square. So tan square, root of tan square is tan theta. So what happens here? Cos tan is sine over cos, right? And then the cos to cos also cancels. Do you see? So basically, finally, you have to integrate sine theta from where to where? From 0 to pi over 4. Okay, so what do we get when we integrate sine theta? Sine integration is minus cos theta, limits from 0 to pi over 4. Minus cos pi over 4, in the middle minus again, minus cos 0. Do you see? Because we had to input the limits. In the middle there is a definite minus sign, right? Minus cos pi over 4, in the middle minus again, and then minus cos 0. So we get here 2 pi times minus cos pi over 4 is minus root 2 over 2, minus minus is plus, cos 0 is 1. Do you agree with me? Simplify, what do we get? 2 pi. We can take the common denominator here, right? So I get minus root 2. Check on this. Is this okay? I took the common denominator. Yeah, the 2 and 2 will cancel, and I get 5 times 2 minus root 2. Is this the show that? Okay, so now looking at the answer that we got, you can see that this answer 5 over 2 times p plus q root 2, it doesn't match with what we got here, right? So basically, what does it mean? It means now what we found here, you need to realize what we just found here. What we just found here by this equation is the curved surface area, right? The curved surface area, the area that comes over here, the curved surface part. But the thing they say here, they have even highlighted the word here. Do you see? They have even highlighted the word. The word is what? Total surface area. Total surface area means get all the surfaces. So you have to get the area of all your surfaces, which means what? Which means what? You also get the two circular faces, because there are two circular faces at the front and at the end, right? So you have to get the areas of those two circles as well. Okay, how do I get the, now, basically there are two circles. The area of a circle is pi r square. All I have to do is what? Get the radius of the two circles. So for the first one, I think you can see the x value is 0, right? Or else we can, yeah. So what's the y value here? I mean, can I know what's the y value I need to use here? How much is it? Basically, here we can start with what? Here we are starting with the theta 0, and here we are ending with theta pi over 4, right? Okay, so theta 0, input theta as 0 for y. Y equal cos 0 when theta is 0. What do we get when theta is 0? Cos 0 is 1. Basically, this value here is 1. Or the radius is 1. Okay, so this end, the circular face has a radius of 1. On the other end, for theta equal pi over 4, y equal cos pi over 4 is how much? Root 2 over 2. Basically, the other circular face, the radius is root 2 over 2. So shall we get the total area? So what's the total area? Total surface area is equal to the answer we got. What was the answer we got? Can I know the answer we got? Pi times 2 minus root 2 plus the pi r square of the of the beginning circle plus the pi r square of the end circle. At the two ends, there are two circles. So we get here pi times 2 minus root 2. Here I get pi. Here root 2 over 2 whole thing square, half pi. Take pi out. 2 minus root 2 plus 1 plus half. Can you all simplify? 2 plus 1 is 3. Sorry, add everything. 2 plus 1 plus half. How much? 2 plus 1 plus half is 3 plus half is 7 over 2, right? 7 over 2 minus root 2. Okay, and then what we need to get the show that has a 2 outside, right? Pi over 2. Yeah, so let's take the common denominator, 7 minus 2 root 2 over 2. Multiplying both up and down by 2 here. And then I'll take the 2 out. So I get here pi over 2. Seven minus 2 root 2. Yeah, you can see the amount of working that went into this, right? Yeah, so this is the final answer, and this looks exactly like the show that they want us to get. Okay, I hope all of you are clear with this. Question number 3. Given that y equal r sech x over 2, look, y equals to r sech x over 2. Where x is greater than 0, less than or equal to, show that dy by dx equals to p over x times q minus x square. Okay, so basically how do we get the show that? Now this is not a standard show that we need to do all the working and show. So y equal r sech means sech inverse. Then we can write this as sech y equals x over 2. Do you agree with me? Sech y equals x over 2. Okay, and then now it's time to differentiate. Differentiate sech y, what do we get? Such differentiation is minus tanh square. Can you please check into the rule? Minus tanh y sech y, sorry, minus tanh y sech y, and then into differentiation of the y, which is dy by dx. You need to look into the rules. Tanh sech differentiation is minus tanh sech. And then there's a y here. So tanh y, sech y, and differentiation of y is dy by dx. X over 2 differentiation is basically half times x differentiation is 1. Are you with me? So I get here dy by dx equals 1 over 2 times. Basically the minus we can take it to the other side as, it divides by a minus. We can put the minus in front. Minus tanh y sech y. Okay, and then it's time to replace. I'll put the minus on top. How do we replace tanh y? Now, by now we know sech y is given to us as what? X over 2. Can you see? Sech y. So let's use the equation 1 plus tanh square y is, sorry, it needs to be replaced, right? Because we had used Osborne's rule, 1 plus tanh square is x square. But in when you make it to hyperbolic, it's 1 minus tanh square y is equal to sech square, because there's an implied product of a sign here. Inside the tanh, there's a sign. Okay, so when there's a product of sign, it needs to be produce a negative when you turn trigonometric to hyperbolic. So basically, I get here sech tanh square is 1 minus sech square. And shall we replace? Sech y is what? X over 2. Sech square y is x over 2 square. Are you with me? So 1 minus x square over 4 is equal to tanh square y. 4 minus x square over 4 is equal to tanh square y. Do you agree? Which means tanh y is root 4 minus x square over 4. Shall we replace? Tanh y is root 4 minus x square over 4 into sech y is x over 2. And then we get here minus 1 over 2 times root 4 minus x square. I can bring the 4 out as a 2. It becomes the 4. The denominator 4 with the root becomes a 2. So then a 2 to 2 cancels here. And I can bring this 2 up, right? So I get here dy by dx equals minus 2 over x times root 4 minus x square. Is this okay? This is to show that. I brought the x in front and wrote the root 4 minus x square, brought this to denominator, this particular 2. I brought it up. You can bring it up, right? You know about this. I think since you all are doing further maths, you should have a good idea about the simplification. Okay, so I did not write the extra steps involved here. I did the method directly. Part B. So they say in part B, solutions based entirely on calculator technology are not acceptable. So you need to solve this by showing the proper working. Okay, fx equals r tan x plus hx over 2. Determine in simplest form the exact value of x for which f dash x is equal to 0. Okay, here to get the f dash x. So fx is r tan x plus r sec x over 2. Can I know the differentiation of r tan x given, right, in the formula book? Check r tan x differentiation. How much is it? So r tan x differentiation is 1 over 1 minus x square given to you, right? And r sec x over 2 is what we found. Minus 2 over x times root 4 minus x square. And then we make it equal to, 0, because it's the differentiation. F dash x, we make it equal to 0. So let's simplify. Minus 2, I'll take it to this side as a positive. 2 times x times root 4 minus x square. Here I get 1 over 1 minus x square. Okay, so you need to solve this equation and make x a subject and then get x answers within this particular range. So how do we get that? We'll cross multiply 2 times 1 minus x square equals x times root 4 minus x square. Is that okay? And then I need to remove this, get rid of this root here. So what I'll do is I'll square both the sides. Shall I square both the sides? What do we get here? 2 square is 4, 1 minus x square, square. Here we get x square, root 4 minus x square. When we square it, it becomes just 4 minus x square. Do you agree with me? So I get here 4 times 1 minus x square is 1 minus 2x square plus x to the power 4. Basically, you know, here a minus b square, a square minus 2ab plus b square. Basically that rule. And here when I open, I get 4x square minus x to the power 4. Is that okay? 4 minus 8x square plus 4x to the power 4 is equal to 4x square minus x to the power 4. So what do we get the final answer? Take everything to one side. Minus x to the power 4 comes this side as plus x to the power 4. 4x to the power 4 plus 1x to the power 4 is 5x to the power 4. And then minus 8x square and minus 4x square, when it comes this side, it gives you minus 12x square and then plus 4. This is okay? So basically, again, it's a quadratic equation. We can consider this as a quadratic equation, right? And then what are the factors? Do we get good answers? We get answers for x square now, right? What are the answers for x square? X square minus 2 and the other answer, other bracket, 5x square minus 2. So basically you get x square minus 2 equals 0 or 5x square minus 2 equals 0. When you solve, we get x square equals to 2. X equals to root 2. Do I need to put plus or minus? No, right? I don't need to put plus or minus because they have told me here x is greater than 0, less than or equal 1. So only positive x figures need to be considered. And the other answer, or 5x square equal to, basically x square is 2 over 5, which means x is root 2 over 5. Okay. But I think we need to check on these answers. Wait, let's check on this. Can you please check root 2 value, because the x value is supposed to be between 0 and 1, right? It's 1.414, so it's jumping the range. So is this a solution? No, not valid. It's out of range. So this is not an answer. Is this one inside the range, root 2 over 5? Yeah, it's inside the range. So basically your final answer, make sure you give that answer only, is 2 over 5. Otherwise you will lose marks. So be careful. Make sure you check the range and give all your answers only within that given range. Okay. Okay, so now we'll move on to question number 4. Okay, they say here they have given you a 3 by 3 matrix for n, and they tell you there here k is a constant. Given that 3 is an eigenvalue of m, determine the possible values of k. Okay, how do we find the eigenvalues? So what do we do? First of all, what you do is you get the now the matrix name is m. So you get what? You get m minus lambda I, right? Get the matrix m minus lambda I, and then we'll get the determinant. So m minus lambda I, shall we fill it? How much is it? M minus lambda I directly. So they have told you, given that 3 is an eigenvalue, right? Which means what? And they're asking you to get the possible values of k. So basically what you do is use your lambda as 3 to figure out the value of k. So here m minus, instead of using lambda I, we'll use m minus 3i. Are you with me? M is 6, K2, K50207. So m minus lambda is 3, I is 1000001 0100001. So when you subtract, we get 6 minus 3 into 1 is how much? 6 minus 3 into 1 is 3. K minus 3 into 0 is k. 2 minus 3 into 0 is 2. K minus 3 into 0 is k. 5 minus 3 into 1 is 5 minus 3 is 2. 0 minus 3 into 0 is 0. 2 minus 3 into 0 is 2. 0 minus 3 into 0 is 0. 7 minus 3 into 1 is 4. So this is the m minus 3i matrix. Are you with me? Normally we take a minus lambda. Here a is matrix m. So m minus 3i is this matrix. And then what do we do? If it's an eigenvalue, then a determinant m minus 3i should be what? Should be equal to 0. Can you all get the determinant of this matrix? Use plus minus plus. And let's quickly get the determinant. So plus 3 times when you input the matrix. 2004 minus k when you remove k2, remove the row and column. 04, next one plus 2, remove the row and column. When you remove the row and column, it's k220. So we get here plus 3 times, 2 times 4 is 8, minus 0 into 0 is 0, minus k times, k into 4 is 4k, minus 2 into 0 is 0, plus 2 times, k into 0 is 0, minus 2 into 2 is 4. Are you with me? So I get here 24, minus k into 4k is 4k square, 2 into minus 4 is minus 8. Are you with me? Determinant is equal to 0. So I get here 0 equal, or we can say 4k square. 24 minus 8 is how much? 16, and you get k square equal 16 divided by 4 is 4. So k equals, when you root it, it's not just root 4, it's plus or minus. So k equals to plus 2 or k equals to minus 2, because they say determine the possible values in plural. So they ask you to determine the possible values of k. So the possible values of k are plus 2 and minus 2. Are you with me? Then in part B, they say given that k is what? Negative. Can you see? Given that k is less than 0, which means what's the k value that we are going to go with? We are going to go with the k value minus 2. Given that k is less than 0, determine the other eigenvalues of m. Okay, so you have to solve the equation, get the other eigenvalues. So shall we get the other eigenvalues? So how do we do that? First of all, write matrix M. 6k was minus 2, right? 6 minus 2. Can you all tell me the other part? 6 minus 2, 2. Minus 2, 5, 0. 2, 0, 7. So we get here m minus lambda I. Shall I directly write it? M minus lambda I, you know, this I is the identity matrix. It's only going to affect the, since the identity matrix has elements only in the main diagonal. The main diagonals are made up of 1 with lambda. The main diagonals will be made up with lambda. So you have to subtract the main diagonals by lambda here, right? Directly. 6 minus lambda, the other two stay the same. This is going to be 5 minus lambda 0. This is 2, 0. This is 7 minus lambda. Okay, so then let's get determinant of m minus lambda I. Plus minus plus. So plus 6 minus lambda, remove the row and column. 5 minus lambda 0, 0, 7 minus lambda. Minus minus 2, right? Minus minus 2. When you remove the row and column, minus 2, 2, 0 and 7 minus lambda. And the last one, plus 2, remove the row and column with 2, we get minus 2, 2. 5 minus lambda times 0. Are you with me? Is this correct? Are you checking it? So I get here 6 minus lambda into 5 minus lambda times 7 minus lambda. The other part is not needed because it's multiplied with 0, right? Over here I get plus 2 times minus 2 into 7 minus lambda, which is how much? Plus 2 into minus 2 is minus 4, right? Because this part is again another 0. So no need to take that. This one plus 2 into minus 2 into 0 is 0, minus 2 times 5 minus lambda. So simplify 6 minus lambda, 5 minus lambda, 7 minus lambda, minus 4 times 7 minus lambda, 2 into minus 4 times 5 minus lambda. Are you with me? So I'll try to first, before I open the large bracket, let me open these two brackets to see whether there is something I can take out. This is minus 4 times 7 is minus 28. 4 into minus lambda is plus 4 lambda. Minus 4 into 5 is minus 20. Minus 4 into minus lambda is plus 4 lambda. So I think you can see we get here plus 8 lambda minus 48. Is it possible to take something out? 8, right? And is it common with the other brackets? If you take 8 out, what do we get? We get 6, right? 48. So instead of taking just 6 out, take minus 6 out. When you take minus, because I want to use get the same as over here. When you take minus 8 out, sorry, minus 8 out, this becomes minus lambda plus 6. Are you with me? So can you see that these two terms are now having a common person? Who is common to both of them? Two parts. Minus lambda plus 6 or 6 minus lambda is common, right? To both of them. 5 minus lambda, 7 minus lambda weights here. And the other side you have minus 8. Do you agree with me? 6 minus lambda times, here you open the bracket, 35 minus 5 lambda minus 7 lambda plus lambda square minus 8. This gives me lambda square minus 12 lambda. How much is 35 minus 8? Can you all factorize? What are the factors here? Can I know the factors here? Then these are, you make your determinant 0. So you get 6 minus lambda 0, which gives you lambda is 6. Lambda minus 9 is 0, which gives you lambda is 9. Lambda minus 3 is 0, which gives you lambda equals 3. Are you with me? So these are the 3 lambda values. That's what they wanted you to find, right? So they wanted you to find the values of lambda. Determine the other eigenvalues of m. Is this clear? The next part, the last part, determine a normalized eigenvector corresponding to the eigenvalue 3. So calculate the normalized eigenvector corresponding to eigenvalue 3. Part C for lambda equal 3. Here to get not just the eigenvector but the normalized eigenvector. What equation do we use? Ax equals lambda x. So let's input the value. A is, can you all tell me the A matrix? Who is the M, right? Yeah, mx. So in this case, I'll use mx. How much? Minus 250, 207 mx. The eigenvector will be a column vector with 3 elements, x, y, z. Lambda is 3 times x, y, z. Are you with me? Let's simplify this equation. Solve and get the values of x, y, and z. Simplify. How does it simplify? 6x minus 2y plus 2z. Here you get minus 2x plus 5y plus 0. Here you get 2x plus 0 plus 7z. 3x, 3y, 3z. First equation, 6x minus 2y plus 2z equals 3x. Can it be simplified? 6x, 3x, when you subtract 3x minus 2y plus 2z. So leave it like that. The other equation, minus 2x plus 5y equals 3y. Minus 2x equals, or we'll take 2x to the other side. Plus 5y minus 3y equals plus 2x. 5y minus 3y is 2y equals 2x, which gives you y equal x. The last one, 2x plus 7 is z. Equal 3 is z. 2x equals 7 minus 3 minus 7 is minus 4 is it? So z equal minus, or we can say x equals minus 2 is it? Are you with me? Okay, so now what you can do is input values for x, y in such a way so you can get the least multiple, or it can be, I mean, you can put any value you want, but at the end try to give the simplest multiple. So for example, here since x is equal to minus 2 z, it's best that we go with maybe z equal 1, yeah, or z equal minus 1, 2 minus 1, right? Yeah. So you can go with z equal minus 1. If z is minus 1, x equals minus 2 into minus 1 is plus 2. So x and y are equal, y also becomes 2. So actually it could be any multiple of this. Any multiple of 2 minus 1 is correct. Even any negative multiple is also correct. Minus 2 plus 1, they're all correct. Okay, any multiple of this fractional multiple is also correct. However, the thing is they want us to not just find the eigenvector. They want to find what vector? The normalized eigenvector. So when you do normalized eigenvectors, all our answers will start to look the same. So what do we do here to get the normalized eigenvector? Get the magnitude. Get the magnitude of this vector first of all. What do we get? Root 9, which is 3, right? Are you with me? Then normalized eigenvector. So what is the normalized eigenvector? 2 over 3, 2 over 3 minus 1 over 3. Is this clear? Okay, moving to question number 5 in the Jan 2022 F3 paper. It says integration of 1 over root x square minus 3x plus 5 with respect to x. Okay, so how do we do an integration like this? What we do is, now this is specifically this is taught to you in the F3 book. Okay, you learn about these specific types of integration, and this 1 over ax square plus bx plus c with the root, you learn it very specifically. Okay, so I'm going to apply that theory. What's the first thing you do here? You must complete the square. You have to complete the square and give it in the complete square format. So what do we get here? X square minus 3x plus 5. We write it as, first we'll complete the square. X square minus 3x plus 5 can be written as what? X minus half of, yeah, so 3 over 2 square minus the square of 3 over 2 is 9 over 4 and plus 5, right? So can I know the x minus 3 over 2 square minus 9 over 4 plus 5 is plus 11 over 2. Okay, so we'll input that value here. 11 over 4, sorry. Okay, so then we'll input that value here. X minus 3 over 2 square plus 11 over 4 with respect to x. Okay, so then what is the next thing we do? The next thing that we do is normally, if you can directly apply these rules, these are the rules, right? These are the rules that are given in the F3 book. So I've taken the rules, you have to apply one of these rules over here. But if you can't directly see it, what they do in the textbook is they use this substitution. Do you remember? Let u equal x minus 3 over 2. This is the substitution we use. And then we convert the dx sum to du completely, entirely. It's a substitution. So what do you get here? Du by dx equals 1, which means du equals dx. Do you agree with that? So shall we substitute? So this becomes integration of 1 over root x minus 3 over 2 is u. So that becomes u square plus 11 over 4. And dx becomes du. Are you with me? Okay, so now it looks, now you have to look at which format this looks most familiar with. Can you see it should be one of the rules either out of 8, 9, 10 or 11. Which one does it look mostly familiar with? Sorry, this is another, there's another set of rules with A, right? We'll take that those rules. Yeah, so I have taken the rules from the formula book as well. So these are the rules provided to you under the F3 section. Under the different in the F3 section. So you can see the rules provided to you. So this is given to you in your textbook as well. So you can see we will use this rule, right? The integration of 1 over 1 over root a square plus x square, right? So then when we integrate, we get r sine x over a. Are you with me? Okay, so then here, so what's your a square here? The u is standing for the x. The a square will be root 11 over 4, right? Because a square is 11 over 4, which means a should be root 11 over 4. Are you with me? Okay, so then let's do the integration. What do we get? So what do we get? The first part is r sine x over a directly. So r sine x means the u, a means the root 11 over 4. Are you with me? So the answer becomes r sine u divided by root 11 over root 4 is 2, right? Over 2. So I can bring that 2 on top. Are you with me? The root 4 comes on top. And then at the end, you must again replace your u back with x. So what is x now? The u is replaced by 2 times. Who is it? X minus 3 over 2. Divided by root 11. So what do we get? R sine 2x minus 3 over root 11. So this is the answer plus c. Don't forget the plus c. Once you're done with the integration. Is this clear? Move to the next part now. Okay, Roman number 2. Integration of 1 over root 63 plus 4x minus 4x square. So again, to integrate, we need to have a x square component. We need to complete the square. So to complete the square, we prefer to have a x square positive, and it needs to have a coefficient of 1. So what you could do is, before the integration, we'll take this certain section 63 plus 4x minus 4x square, and we'll do the completing square part first. So how do we complete the square? I want to have x square positive. So we will take out what? Minus 4. So when we take out minus 4, what's remaining? Sorry, this is 6x, 63. So what do we get here? 63 divided by minus 4. Or else you could take the minus 4 only out from the two relevant people. Let me rearrange this minus 4x square plus 4x plus 63, right? So let me do the completing square. We'll only take these two parts, right? We'll take minus out from both of them, and what's remaining? X square minus x. And the plus 63 stays out. We'll keep it out. Okay, now let's complete the square. What happens here? X minus 1x. So you have to put half the value, right? X minus half square minus square of half is 1 over 4. And plus 63. Now open the bracket with minus 4. What do we get? Minus 4 times x minus half square minus 4 into 1 over 4 is plus 1. And then plus 63. So we get here minus 4 times x minus half square plus 64. Do you agree? Okay, and then we'll rearrange because this is 64 minus 4 times x minus half square. So, okay, then how can we simplify this a little bit further? Okay, so now we all know, now when we do this sum, you know the x minus half square. Now earlier also we took this part to be as our u, right? But you can see now we have a 4 and a u coming here. Can you see? If you look at the rules, we need our x square to be alone. You should not have any other coefficient. So what you could do is, one way of getting around this is, you know, 4 is 2 to the power 2. 2 to the power 2, x minus half to the power 2. Do you see that I can take a common power 2 and take 2 inside? 2 times x minus half, like whole thing to the power 2. Because both of them are having a power of 2, right? So this gives me 64 minus, what is it? 2x minus 1 square. So now our u value can be 2x minus 1. Okay, that's one way of doing it. Or else, yeah, some of you suggested, let's take 4 out from here. And then 4 out from this entire denominator. So that also works. We'll go with this method. Okay, so then we'll integrate now 1 over, what was our sum? Root 63 plus 4x minus 4x square. This is the original sum. So when we integrate, now we just found out that this could be written as what? 63 plus 4x minus 4x square can be written as what? Inside the root 64 minus 2x minus 1 square. Can you see? And now what do? We say we'll let u be what? 2x minus 1. So u is 2x minus 1. That gives us du by dx is equal to 2. Which means when you make x a subject, dx equals du divided by 2. Agree? So we are going to turn our entire sum into u now. We are going to convert the entire sum in x to u. Okay, and we need to make it look like one of these formats. We have to make it look like one of these formats. Okay. So when we continue, when we substitute, what do we get? Integral of 1 over root 64 minus 2x minus 1 is u, which means 2x minus 1 means u square. And dx is replaced as du over 2. So you could take the half out, du over 2 the half. And we have integration 64 minus u square du. Can you see we have now successfully converted the entire sum into u. And now we have to go through these formats and then select the most relevant one. So we have something like a square minus x square inside a root. Do you see? Which format does it work with? A square minus x square, the whole thing root. So it works with what? Arc sine. Arc sine x over a. Can you see? Arc sine x over a. Who is your a value? This is 64 is a square. Which means a is 8. Root 64. Root 64 is 8. So we get here the answer is arc sine, but there is a half already outside. So half arc sine. It's arc sine, right? Check the rules properly whether it's arc sine or arc sine. It's arc sine. Can you see? 1 over root a square minus x square is arc sine x over a. Arc sine in our case, we have what? The x value is not x, it's u. Arc sine u over a is 8. And the plus c, and at the end, make sure you replace the u back with what we replace it by. What was u? 2x minus 1 over 8 plus c. Is this clear? So this is the, so this is the answer. Half arc sine 2x minus 1 over 8 plus c. Okay, so now I'll move to question number 6. So you can see question number 6 is the reduction formula question, right? Okay, so we pay attention. Now they have given you the IN. So it's integration of EX sine to the power NX with respect to X. Show that this integration is equal to, okay, so pay attention to show that, because this show that tells you the path you need to go. So it's EX sine n minus 1x over n square plus 1. You can see the sine power has reduced, right? And sine x minus n cos x, okay. And then here we have in minus 2. By the way, what does in minus 2 mean? If in is e to the power x sine to the power nx, what does in minus 2 mean? It means integration ex sine to the power n minus 2x. So this is what you get over here, okay? Now the question is the integration technique. What integration technique do we do? Because in certain questions we used to break sine as sine n minus 1x into sine x, or sine n minus 2 power n minus 2x into sine square. We break it up and do in different ways. But here the sine to the power nx is not alone. There's another ex with it. So what is the most familiar technique we should go here? We can go with integration by parts. Integration by parts. So what's the integration by parts rule? U dv by dx or uv dash is equal to uv minus integration v du by dx. So this is the rule. Basically, u is the person you choose to differentiate, v is the person you choose to integrate. Now you can see sine's power has reduced, right? Because the power of sine has reduced, and you also need to show sine to the power n minus 2. Definitely, who should be the person to differentiate? We will differentiate sine to the power nx, because when you differentiate, the power reduces. Are you with me? And then ex will be my dv by dx of the v dash. Are you with me? Okay, so shall we use the rule? So what happens when you integrate? So the integration, let me write again, in e to the power x sine to the power nx. Shall we write our u and so what's our u here? The u is sine to the power nx, right? Can you all tell me what's the du by dx? Can you differentiate? First priority for the power, n comes front, sine x to the power n minus 1 into sine x differentiation is cos x. Are you with me? So this is the du by dx. And then what about the v? The dv by dx was? The dv by dx is ex, the v dash. So when you integrate and get v, what do you get? Integration of ex is ex. Shall we apply these parts by integration rule now? So the rule is given here. Shall we directly apply? So when you integrate uv, so who is your uv? U is sine to the power nx. V is e to the power x. Are you with me? Minus integration. V is again e to the power x. Du by dx is n sine to the power n minus 1 x cos x dx. Is that okay? Shall we rearrange it? Ex sine to the power nx minus, if there are constants, you can bring it out of the integration. Who is a constant here? N is a constant, so I can bring it out. I get here ex sine n minus 1x cos x dx. Okay, so we come to this point. Okay, and now you can see, now again we come to an integration in this stage, right? Okay, now this particular expression looks a little bit different. Okay, and you can see now we have a little bit of an issue here. Why? Because you have like the integration of 3 x functions. There's a ex, there's a sine to the power n minus 1x, and there's a cos x. Now we can use integration by parts as long as there's a product of 2 x functions. Here there's 3 x functions. How do we work with something like this? How can we fix this? How can we, integrate this? What technique do we do here? Okay, so even here now, okay, so we can do this by using integration by parts. See how we can pull this off. What you do here is, if you look at the integration in P4, you have learned the reverse product rule, right? Which is f dash x fx to the power n. Are you familiar with this rule? The integration. What happens when you integrate f dash x fx to the power n? Fx to the power n plus 1 over n plus 1, right? So if you look at this, what we will use for f dash x fx to the power n, I will use this guy. Look at this. Now see who is the f dash x and fx to the power n. Okay, so now how do we integrate this? You can see here the sine x. The sine x is going to be your fx. Can you see? Sine x, and then the power n in this case is the n minus 1. I'm just taking this part and rearranging it. Sine x, the power n minus 1, and then you can see the f dash x is supposed to be the integration of the fx, right? Ignoring the power, if you keep the power aside, fx is differentiation f dash x. So you can see what is the differentiation of sine x. Sine x differentiation is directly cos x. So can you see that that answer is going to give you what? It's going to give you sine x to the power n minus 1. You have to add 1 to the power, right? N sine x to the power n divided by n. Okay, so when we try in this method, I think we can see there is a problem, right? Even though this applies, even though we could apply the reverse product over here, you can see that the answer now, the show that, now we always try to keep the show that in our mind, right? So in the show that you realize that we need to get, the power of sine needs to reduce. It needs to reduce, not increase, because we need to get sine n minus 2x because it needs to keep on reducing. Right, reduction formula. But you can see when I go in this technique, the power of sine is increasing, and thereby, I think if you substitute, you will see that you will there will be an issue here, right? So what we'll do here is we'll try another technique here. The other technique is where we use. Okay, I will erase this. We will use the technique of what? Again, we will use the integration by parts. What we will do is we'll use this entire thing as our u. This entire thing is u. U is the person that we differentiate. And for the differentiation, what we'll do is we have a product here. So we will use product rule for the differentiation of u. Are you with me? And then the v dash is the dv by dx is ex. Ex is dv by dx. Shall we try? So what happens here? Again, we will name our u and du by dx. So u is, so look at this, u is sine to the power n minus 1x into cos x. Are you with me? Du by dx is what? So when you're differentiating du by dx, what should you do? The differentiation, you will apply the product rule because you have differentiate. So in product rule, one person stays while the other differentiates. So here, sine n minus 1x stays while cos x differentiates. What does cos x differentiate to give you? Cos x differentiation is minus sine x. Are you with me? After that is done, so first I integrated the differential with the cos x, and then product rule, you write plus, and now you keep the cos x weighting, right? Now the cos x weights while sine to the power n minus 1 x differentiates. So what's the differentiation of sine to the power n minus 1? Differentiate the n minus 1, first the power, right? The n minus 1 comes front. Sine x to the power, what happens? N minus 1, you have to subtract 1 from the power. It becomes n minus 2. Are you with me? Subtract 1 from the power, and after done with the power, so this is the power. After you're done with the power, go inside and differentiate sine. Sine differentiation is cos x. Are you with me? So this is the this is using the product rule. Okay. So let me rearrange this a little bit. Du by dx is equal to minus sine n minus 1 into n minus 1x into sine to the power 1x gives you sine nx. And then here you get plus, we'll rearrange n minus 1. Cos x is cos square x. Sine x to the power n minus 2 is sine to the power n minus 2x. Are you with me? Yeah. Okay. So I think you can see now we are generating the power n minus 2. Can you see? Which is what we need to which is what we need to see here. Okay, so let's keep the integration by parts. Okay, the dv by dx is ex. So what happens when you make it v? Integration of ex is ex. There's no change. So shall we now apply the Parts by integration rule, I'll take it a little bit down because I won't have enough space otherwise. Ex sine to the power nx stays, while here n times, I'll open a big bracket. Can you see? I'm opening a large bracket here. So we will be applying the integration by parts rule, right? So when you apply u dv by dx, integration is uv minus integration v du by dx. Are you with me? So I will be applying this rule here. Okay. So let's apply. So uv, who is our u? You can see I have written the u and v here. U is sine n minus 1x cos x. U, v is ex. uv minus integration v. U dash, the du by dx. So who is the du by dx? So we have written that, right? So du by dx is minus sine to the power nx plus n minus 1 cos square x sine to the power n minus 2x. E to the power x sine to the power nx minus n times. This becomes ex sine n minus 1x cos x. Are you with me? So over here, I have used this entire answer. So now we need to open the integration. Because we need to expand. There are two terms here. Do you see? Minus sine to the power nx and n minus 1 cos square x sine n minus 2x. This needs to be expanded with the integration ex. Shall we expand? Minus, shall I immediately expand? Can you all see what's happening here? Ex multiplying with minus sine nx is minus ex sine nx. But that also again multiplies with this minus sign. Which gives you what? Which gives you plus integration e to the power x sine to the power nx. Are you with me? And then the next part. You open the ex with n minus 1 cos square x sine n minus 2x. So this is a plus mark in the middle. Along with the minus integration ex will give you what? The sign is a negative. The sign is a negative. Ex multiply with n minus 1 cos square x sine to the power n minus 2x dx. Are you with me? And there's the large bracket out here. Ex sine to the power nx. Are you okay with that? With the sign? Is it clear? Okay, so you can see that I have opened the bracket. I hope the negative integration ex, I open the bracket with the negative integration ex, and how I input the signs, I hope it's clear. And now the large bracket can be opened with the n. Shall we open it with n? There are three terms here. All these three terms will get the n coefficient. So I get here n ex sine n minus x cos x. And then here, of course, it's going to be minus, right? Minus with plus. Minus n integration ex sine nx, sine to the power nx dx. And here minus n, when you open with minus, it's going to be a plus n times. Shall we take the terms out, the constants out? N minus 1 is also a constant, right? N minus 1 ex integration cos square x sine to the power n minus 2x dx. Are you with me? So this is all of this is equal to in. So I think you can see here this in equals ex sine to the power nx minus n times ex sine to the power n minus 1x cos x. And then what happens here? Minus n integration of ex sine nx is what? This is the first person that we defined, right? Integration ex sine to the power nx is in. So this is basically n times in. N times in. And now we run into a problem. Okay, what's the issue we have now? How do we integrate ex cos square x sine to the power n minus 2x? How do we integrate something like this? So what's the technique you use here? Now you know you need to create any integration with ex and a power of sine. He's producing you some I power. Now you need to produce in minus 2, right? e to the power x sine to the power n minus 2x needs to be produced. So how do we produce that? Now you have ex sine n minus 2x here, but there's a cos square, an extra cos square. So can you tell me some kind of a way that we can deal with this cos square x? Into the cos square. So what can we do about the cos square x? So for cos square x, I will use 1 minus sine square x. Why? What's the advantage of using 1 minus sine square x? I will continue with only this part. Why? Now I'm going to open the bracket with what? Ex sine n minus 2x with 1 minus sine square. Do you see why? What is the advantage of doing that? So we get here when you open ex sine to the power n minus 2x. Can you see? So this part comes independently now. And the other part minus ex sine to the power n minus 2x. When you multiply with sine square x, what do you get? What do you get here? Sine to square, sine to the power n minus 2 multiply with sine square. What do you get here? The powers add, right? Sine to the power n minus 2 with sine square. Then it becomes sine to the power nx. Isn't it? So this is sine to the power nx. And now both of them are integrating with respect to x, right? And this isn't this what all our in is about? Didn't I just describe at the beginning of the sum? Integration ex sine n minus 2x is in minus 2. And integration ex sine nx. Integration mark is there available to both of them. Can you see? This is in minus 2. This is in. Are you with me? This is n minus 1 times. Inside bracket, this is in minus 2 minus this is in. Are you with me? So we are almost at the end of the sum. All we need to do now is to make in the subject. Okay, so we'll take all the in terms to one side. So in, the minus nin becomes as plus nin. And we have to open this bracket. Shall I bring this part here as well at once? What do you get here when you open this bracket? n minus 1 into minus in, isn't it? So when you bring this term also to the other side, what happens? It becomes plus, right? Because n minus 1 into minus in becomes a plus. n minus 1 in. Are you seeing that? This is a plus now. This is a plus now because this term was a negative. You bring it to the other side, it's positive. Now let's write the remaining terms. Let's write the remaining terms. What do we get here? Ex sine to the power nx minus nex sine to the power n minus 1x cos x. The minus nin is gone, plus n times n minus 1 times in minus 2. That's what's remaining here, right? Are you with me? Okay, so now let's simplify. We have to get the show that. Now it's a matter of simplifying to get this show that, isn't it? We have to get this show that ex sine n minus 1x is taken out. Okay. Okay, so let's open the bracket. I'll take the in out of this entire set. So I get here 1 plus n minus 1. Agreed? Do you agree with me? 1 plus n times n minus 1. I think you saw in the show that, do you see in the show that they have over here ex sine n minus 1x taken out as common from the two terms. Can you see? Ex sine n minus 1x is taken out, isn't it? So here I have a ex sine n minus 1x from here, but I need to take a ex sine n minus 1x from here as well. Okay, so we will try to get the show that. So we'll take ex and a sine n minus 1x out. Are you aware what happens when you take something out? So we are going to take it out from both of these terms, right? When you're taking it out from both of these terms, it means you're dividing that person. Are you with me? So you already have ex sine to the power nx and you want to take out ex sine n minus 1x out. Are you with me? Minus n ex sine n minus 1x cos x. So from this guy also you are taking a ex sine n minus 1x out. Like basically we do it very easily. Now here you can see ex and sine n minus 1x comes out very easily. But the thing is, over in the other one, you have to think a little bit and take it. Okay. Then you get here plus n times n minus 1 I n minus 2. So what do we get here? Over here I get I n times. Can you all see what happens? 1 plus, can you see n into n is n square. The minus 1 n and plus 1 n cancels. So I get here I n times 1 plus n square equals ex sine to the power n minus 1x. What happens over here? You can see ex to ex will cancel out, right? But what about sine to the power nx divided by sine to the power n minus 1x? Yeah, that when you're dividing, the powers are subtracting. When you're dividing, the powers are subtracting sine x. So we can write the powers. N, you have to subtract with n minus 1. Are you with me? Division means powers are subtracted. Here also ex cancels, sine n minus 1 directly cancels. So you get minus n times cos x. Are you with me? Plus, what do we get here? n minus 1 times I n minus 2. So I think we are almost there with our show that, right? I n equals ex sine to the power n minus 1x over 1 plus n square, or n square plus 1 as to show that. Inside the bracket, this is sine x to the power n minus n plus 1. Can you see? N minus n plus 1. This bracket over here, n minus n plus 1. The n and n cancel, so you get sine to the power 1x, just sine x. Minus n times cos x. And here again, n minus 1, you divide by n square plus 1, because this n square plus 1 comes down as a division to both the terms, isn't it? Into I n minus 2. So isn't this the show that? Yeah, so this is our show that for 6 marks. Can you see? Okay, so then the thing is, yeah, so then they say in part B, hence find the exact value of this person, right? Ex sine x to the power 4. So basically, you can use the show that, right? So you have the show that is given to you. We also got it in an event. You have some trouble with this show that. In the exam, you can definitely go for part B without taking a lot of time, okay? Trying to figure out part A, but you could go to part B and get the part B answer and get the full marks, okay? Shall we try part B now? Hence, find the exact value. So basically, this is I4. Are you? Do you agree with me on that? This is I4. Okay, how do we get I4? I4 means you go to the equation, replace all the n values with 4. What do we get then? Ex sine cube x, right? Sine 4 minus 1. Or what happens here? 4 square plus 1. So that is 16 plus 1, 17. Inside bracket sine x minus n is 4. Minus 4 cos x plus, replace the n's with 4. We get 4. 4 minus 1, that is 3. Over 4 square plus 1, that's 17. I2. Are you with me? And then you can see we have definite integration here, 0 to pi over 2. So the parts that are done with the integration, you could apply the limits to make it easier. At that stage itself, you could apply the limits to make it easier for you. Okay. Shall we apply the limit here? What do we get? When you replace x with pi over 2, what is sine pi over 2? Sine pi over 2 is 1, right? So you get here e to the power pi over 2. Sine pi over 2. Sine pi over 2 is 1. So sine, cube of 1 is simply 1. Are you with me? And then again, sine pi over 2 is 1 minus 4 times cos pi over 2. Cos pi over 2 is 0. Okay. And then we are done with that part. And then in the middle minus. Now replace 0. So what happens when you replace 0? You get e to the power 0. I think you can see sine 0. Sine 0 is 0. And then power 3. So that's all 0. And 0 multiplied with the whole bracket is again a 0. So basically, because sine 0 is 0, it multiplies with all of them. It becomes a 0. The entire term is a 0. Agreed? That part is done. Then in here we get 4 times 3, 12 over 17. 12 over 17 times I2. Shall we go ahead with I2 now? This is e to the power pi over 2 divided by 17 plus 12 over 17. I2. How do we go with I2? So again, go to the IN equation, replace n with 2. So what happens here? Ex sine to the power 2 minus 1 is 1x, sine 1x, over replace n with 2, 2 square plus 1. That is 2 square is 4, 4 plus 1 is 5. Bracket sine x minus n is 2, right? Minus 2 cos x. Are you with me? So while you're writing over here, it's better you keep your finger over here to go ahead with, ahead with everyone, so you don't miss anyone. Okay. Plus it's replace then with 2, so you get 2 into 2 minus 1 is 1 over 2 square plus 1 is 5. 2 minus 2 is I naught. Are you with me? And then again you have to put the limits to the part where you're done with the integration. E to the power pi over 2 over 17 plus 12 over 17. We have to apply the limits to this part. Okay, so I'll use a large bracket here. And we'll use a small bracket here because we need to apply the limits part. Now this part is out of the integration, 0 to pi over 2. So again, the same story. E to the power pi over 2. E to the power pi over 2. Sine pi over 2 is 1. Divide by 5. Bracket. Sine pi over 2 is 1. 2 cos pi over 2. Cos pi over 2 is 0. Minus. Again, you replace the x with 0. E to the power 0. Sine 0. Sine 0 is a 0, which makes the whole thing 0. Right, that part is done. And then we have plus 2 over 5 I naught. Are you with me? Be careful with the brackets because this 12 over 17 is supposed to multiply with everyone. So I get here I4 equals e to the power pi over 2 divided by 17. I'll open the bracket, 12 over 17 into e to the power pi over 2 divided by 5. Okay, this is entirely one term. And then 12 over 17 into this and 12 over 17 into this, right? 12 over 17 into 2 over 5 I naught. Okay, we need to find I naught. How do we find I naught? Are we going to use the reduction formula again? No, for I naught, we can directly use n as 0 here and get the integration. So what's I naught? Go to this equation. I naught is integration of Ex sine to the power 0 x. Are you with me? Sine to the power 0 means just integration. Sine to the power 0 is 1. So basically integration of Ex is Ex. Can you see? I naught is just simply Ex. Okay, so we'll input the value here. Plus 2 over 5 I naught integration is Ex, but you need to make sure to remember to put the limits. What are your limits? 0 to pi over 2. I naught is Ex. Yeah, sorry. So this part I should erase and write the I naught value down, right? Yeah. And this part is not there. Yeah, we need to put the I naught value in the next step. E to the power pi over 2 divided by 17 plus 12 over, can I know how much is 17 times 5? 85. E to the power pi over 2. 12 times 2 is 24. 17 times 5 is 85. I naught we just found out is Ex. So Ex give your limits from where to where? 0 to pi over 2. So we get here I4 equals e to the power pi over 2 divided by 17 plus 12 over 85 e to the power pi over 2 plus 24 over 85 e to the power pi over 2 minus e to the power 0 is 1, right? Because for this we get e to the power pi over 2 minus e to the power 0, which is 1, and that needs to be multiplied with 24 over 85. So minus 24 over 85 times e to the power naught, which is 1. So just 24/85. Okay, yeah. So this is your answer. This is the answer for I4. So if you all don't want to input the limits at the very beginning, you could continue the integration without putting the limits and get the entire full answer in terms of x. And at the very last stage, you could input the limits. That's also okay. Okay, so here I have input the limits the moment the integrations are done. Okay, but we could input the limits okay, at the very end. So giving, yeah, what was the answer? Yeah, they say giving your answer in the form a e to the power pi over 2 plus b, where a and b are rational numbers to be determined. So do we have a e to the power minus pi over 2, a e to the power pi over 2 plus b? Yeah, right? So this is I4 equals e to the power pi over 2 is a common number here, right? Yeah, we can simplify further. And minus 24/85 comes separately. Yeah, we can simplify this, right? Yeah. What do we get here? Yeah, 1 over 17 plus 12/85 plus 24/85 is 41 over 85 e to the power pi over 2 minus 24/85. So a e to the power pi over 2 plus b. Okay, so you get the values of a and b. Can you see? A and b are rational numbers. So we got rational numbers here for both a and b. Is this clear? Okay, so moving on to question number 7. They say the line L1 has equation x minus 3 over 4 equal y minus 5 over minus 2 equal z minus 4 over 7. The plane has equation 2x plus 4y minus z equal 1. So they have given you the Cartesian equation for both line and plane. They are asking, they are saying the line 1 intersects the plane at the point P. So the line and plane is intersecting. Determine the coordinates. 3 marks. Okay, what do we do? First thing is when they give you the line in this Cartesian form, you must remember what each of these represent. Do you remember what it represents when you have it in the form x minus a over m, y minus b over n, z minus c, right? Over L. Do you remember how this is converted to the vector form of a straight line? At the top you get the position vector. At the bottom you get the direction vector. Can you remember? The position vector. This is a theory. A theory you learn in your F3 book, F3 vectors. Position vector is ABC that you get on the top. Direction vector is M and L. Are you with me? And then we write the vector equation of a line R equal A plus TB. So this is something that you learn in R equal A plus lambda B. You can see R equal A plus lambda B. This is the format you learn in P4. Okay, where A represents what? Where A represents the position vector on the straight line, B represents the direction vector of the line. So what we can do here is you can see your position vector and direction vector here very clearly. Who is the position vector? 3, 5, 4. All of them are having the minus sign in the middle. So it's directly 3, 5, 4. R equal A plus lambda B is 4 minus 2, 7. R equal A plus lambda B. So when you take it together, I mean, we can add them and write 3 plus 4 lambda. 5 minus 2 lambda. 4 plus 7 lambda. So this is R. Okay, so this is the R. And now what we'll do here is we can take it in now the plane equation. You could leave it like this and just substitute. You can see the x coordinate is 3 plus 4 lambda because here it's all simultaneous to get the cutting point. Or some of you might do it R dot n equals A dot n P. So here you could separate this as what? R is x, y, z into, you could break it like this, right? 2, 4 minus 1. This is what gives you 2x plus 4y minus z. Anyway, we don't need to go in this manner. Directly substitute. What do you get here? 2 times x is 3 plus 4 lambda. Let me write the equation of the plane again. Plane equation is 2x plus 4y minus z equal 1. So replace 2x is 3 plus 4 lambda plus 4 times y is 5 minus 2 lambda minus z. minus z is 4 plus 7 lambda equals to 1. And now what do you do? Solve this equation, make lambda the subject. What do we get? 6 plus 8 lambda, 4 times 5, 20 minus 8 lambda, minus 4 minus 7 lambda equals 1. What do we get? The plus 8 lambda minus 8 lambda cancels. Minus 7 lambda, shall I take it over here? 6 plus 20 minus 4. The plus 1, I'll bring it here as minus 1. Equals on the other side, I get 7 lambda. How much is 6 plus 20 minus 4 minus 1? How much is 6 plus 20 minus 4 minus 1 is 21 equals 7 lambda, which gives me lambda is 21 divided by 7, 3. So lambda value is 3. Now how do we find the coordinates where the line and the plane intersect? Go to the equation. You can see the XYZ coordinates in the equation of the line. Replace the lambda with 3. So that lambda, that specific lambda is the place where the line and the plane meets. The point of intersection, have they given a name? Coordinates of P. So P is, when lambda is 3, 3 plus 4 times 3, 5 minus 2 times 3, 4 plus 7 times 3. What's the coordinate? 4 times 3, 12, 13, 14, 15. 5 minus 6 is minus 1. 7 times 3, 21 plus 4, 25. So P coordinates, right? This is the P question vector. P coordinates 15 comma minus 1 comma 25. So this is the coordinate of P. Is that clear? Okay, the next part, they say the acute angle between line 1 and the plane is theta degrees. Determine to 1 decimal place the value of theta. Okay. So in your F3 book, again, you learn the theory of how to find the acute angle between two lines, between a line and a plane, and in between two planes. So all those theories are clearly given to you in the textbook. So I have written it over here. For angle between line and plane, where line has equation r equal a plus lambda b, and plane has equation r dot n equal p, the acute angle is given by sine theta equal b dot n over modulus b modulus n. Right? So this is provided to you. So now all you have to do is apply the b value is the b is the direction vector of the line. N is the so here n represents the vector who is perpendicular to the plane, right? So in the plane equation, you have to determine the n here. I think our b value is pretty much obvious. We have the direction vector of the line. Using this equation, the plane equation, you have to determine your n. How do we determine the n here? So you know 2x plus 4y minus z equal 1 could be written as xyz dot 2 4 minus 1, right? Because then you get 2x plus 4y minus z equal 1. So basically r dot n equal p. So here your n is 2 4 minus 1. And then your b, the direction vector of the line, we can take it from the equation 4 minus 2, 7. Okay. So now all we need to do is, we need to find the angle. Just use the sine theta equation. Sine theta equals b dot n. We'll calculate b dot n first. B dot n is 4 minus 2, 7 dot 2, 4 minus 1. What happens? 4 into 2, 8. Plus 4 into minus 2 is minus 8. Plus 7 into minus 1 is minus 7. How much is the b dot n answer? B dot n is minus 7. We'll get the modulus b, modulus n also. Modulus b is 4 square minus 2 square, 7 square, square root. Can I know how much this is? How much is this? Root 69. How much is modulus n? 2 square plus 4 square plus minus 1 square root. How much is this? 2 square plus 4 square plus minus 1 square. How much? Root 21. Okay, now we are ready. We'll input the values. Sine theta equals b dot n is minus 7 over modulus b is root 69. Modulus n is root 21. And the whole thing is inside the large modulus sign. Why is the large modulus sign there? To remove the negative sign. in B dot n, because we need to get the acute angle. The acute angle, to get the acute angle, you remove the negative, get the modulus, sine inverse 7 over root 69 times root 21. Remove the negative sign because of the modulus. They want the answer determined to 1 decimal place the value of theta. Can I know the value here? 10.6 degrees, correct to 1 decimal. This is in degrees. Yeah, they want the answer. Yeah, they say the value of theta in degrees. So calculator must be degree mode. Type sine inverse of this value and you should get 10.6 degrees. Are you all okay with that? Okay, so moving on to the next part, they say the line 2 lies in the plane and passes through P. Okay, now what's P once again? P is the place where the line 1 and the plane intersects, right? This is the line 2 lies on the plane and passes through P. Given that the acute angle between line 1 and line 2 is also theta degrees. Determine a vector equation for line 2. Okay, but how do we do this? I think the best thing is to draw a quick sketch. Draw a quick sketch. So this is the plane. Okay, so your plane intersects with line 1. Line 1 was somewhere like over here. And then you intersect the plane. Line 1 intersects the plane and goes, right? And then the angle in which line 1 intersects the plane was theta. Isn't it? So we found the acute angle between the line 1 and the plane. Theta degrees. Now they say line 2. Okay, line 2 lies on the plane, which means line 2 is something that is on this plane and passes through P. What is P? P is the place where line 1 intersects the plane. So that is basically this is P. Okay, so line 2 passes through this point P. And also what? And also what? Line 2 makes an angle theta with line 1. How do you draw line 1? Can you see the way to draw line 1 here? The easiest way to draw line 1 here is if you draw it like this. Now line 1 is, sorry, line 2 is supposed to be on the plane, right? It's supposed to be on the plane. Okay, draw this properly. Can you see the line 2? So this is your line 2. Can you see the line 2? So the line 2 also, as you can see, when you draw it over here, it's the line 2 is definitely lying on the plane, and it also makes an angle theta with the line 1. Okay. Okay. So now your task is to determine the vector equation for line 2. Okay. How do we get the vector equation for line 2? Okay, so now our task is to find the equation of line 2. Okay, so when you take line 2, I think you can see we already know a position vector on top of line 2, right? Because point P is on top of line 2. So we already have the position vector. What's the only thing you need to know to find the equation of line 2? The only thing you need to know is the direction vector. If you can find the direction vector of line 2, we can substitute into R equal A plus lambda B, where A is the position vector, B is the direction vector. So we are currently missing the direction vector. Okay. Right. So now let's see how to find the direction vector. Okay. So I'm going to go in a little bit of a different technique here. So what I see here is on line 1, I know the equation of line 1, right? We know the position vector on top of line 1. Now line 1 equation was A plus lambda B. The position vector on top of line 1, can you see 3, 5, 4 is actually a coordinate on top of line 1. Here, the 3, 5, 4 is a position vector on top of line 1. Do you agree with me? So it could be somewhere, anywhere on top of line 1. So I'll mark that point as point A. Point A is 3, 5, and 4. Can you see? 3, 5, 4 is the position on top of line 1 when the lambda is 0, basically. Okay, basically when the lambda is 0, 3, 5, 4 is a coordinate that lies on top of line 1. If you all want, you could apply lambda is 1 or lambda is 2 or any value to lambda and just generate a coordinate on top of line 1. Okay, the thing is you have to generate a coordinate that lies on line 1. Okay, so this is a coordinate who is lying on line 1. Now, what I'll do is this. I will create a perpendicular from the point A towards the plane. Okay, so from this point A, I'm creating a perpendicular towards the plane. So So then, do we know the direction vector of the perpendicular vector? Now from A, we are drawing a perpendicular to the plane, right? Okay, from A, I'm creating a perpendicular to the plane. So do I know this the direction vector of this plane, of this particular line? We know the normal to the plane. The normal to the plane is what we call as r dot n equal p, right? R dot n equal p. Can you see here? R dot n is what? N is 2, 4, minus 1. 2, 4, minus 1 is the direction vector of direction of any vector who is perpendicular to your plane. So it could be a multiple of 2, 4, minus 1. Any multiple of 2, 4, minus 1 represents a vector who is perpendicular to our plane. Do you agree with me? So basically the direction of this, the direction of the perpendicular vector, this is n. This is the n. So then what I could do here is, let's say this is the, okay, so what we could do here is, I'm going to try to find this coordinate here. Okay, I'm going to try to find another coordinate on top of line 2. Are you seeing what I'm trying to do here? Let's say the place where the place where A meets the plane is x, and you need to realize that x is again on top of line 2, right? Because of this angle theta. It's when you draw the perpendicular, the place where the line that you draw perpendicular to the plane from A meets the plane and on top of line 2. And let's say that is x. So what I'm trying to do here is, now I'm trying to find this x coordinate. I'm trying to find the x coordinate. How do we find the x coordinate? Okay, first let's get the normal to the plane. Normal to the plane from line from A. So what's the normal to the plane from A? The equation. So let's get the equation of line. So what's the equation of the normal? Equation is R. Any equation of a line is R equal A plus lambda B, where A represents the position vector on the line, where B represents the direction vector of the line, right? I'm trying to find the equation of this line. Are you with me? I'm trying to find the equation of this line. Okay, so what is the A and what is the lambda here? Who is A? Do we know a position vector on this line? Yes, we know the exact value of A, which is 3, 5, 4. And don't use lambda now, use a different parameter, because lambda has already been used. Use a different parameter. And then B is the direction vector of this line. Do we know the direction of this line? We know the direction of the line because this is the vector who is perpendicular to the plane. Any vector who is perpendicular to the plane is n. Any vector who is perpendicular to the plane is a direction of n. Okay, anyone, any person who is perpendicular to the plane is having the direction, is a multiple of the direction 2, 4, minus 1. It's a multiple. Okay, so then I'll erase all these. So this what I'm having here is a multiple of n. So then that is 2, 4, minus 1. And to show it's a multiple, that's why the t is over here. And then let's get it together. R equal 3 plus 2t, 5 plus 4t, 4 minus t. So this is the equation or the general coordinate of any line that lies on top of this yellow line, the normal to the plane, the AX line. Okay, basically the equation of AX, that's what I'm finding. Okay, now how do I find the coordinates of X? How do I find the coordinates of X? So X is the place where the line AX meets the plane, right? Don't we have the plane equation? Why am I trying to find the X coordinate? Because the only thing that I'm missing in line 2 is the direction vector line 2 of line 2, right? If I have a coordinate on top of line 2, another one, I can get the XP vector as the direction vector of line 2. XP is the direction of vector of line 2. Because all I'm missing here is the direction. So that's what I did. I drew a normal from this point A to the line, to the plane, and that's the place where you meet line 2. And then I got a coordinate on top of the line and on top of the plane, and we can use XP direction vector to be the direction of line 2. So now I'm finding the coordinates of X. So 2x plus 4y minus z equals 1 is the equation of your plane. So the plane equation, again, I'm solving it with the line equation. Do you agree? The plane and the place where the line AX meets the plane is at X. So I'm solving the equation of the plane and the line AX to find the intersection point. 2 times 3 plus 2t plus 4 times 5 plus 4t minus z minus 4 minus t equals 1. Can you all solve and get me the t value? 6 plus 4t, 4 times 5, 20t plus 16t minus 4 plus t. How much is it? 16 plus 4, 20, 21t. How much do we have here? 6 plus 20 minus 4. So which gives 21t equal 1 minus 22 is minus 21, which gives you t is minus 1. So using the t value, what can we do now? We can get the coordinate of x, the x coordinate. So x coordinate, can you all get it? 3 plus 2t, 2 into minus 1. 5 plus 4t, 4 into minus 1. 4 minus t is minus 1. What do we get? 3, 2 into minus 1 is minus 2 plus 3 is 1. 5 plus 4 into minus 1 is minus 4 plus 5 is again 1. The other one, 4 minus minus 1 is 5. So basically this is the place where the line AX meets the plane. Do you agree with me? 1, 1, 5. And the point P coordinate we found earlier, right? What was the P coordinate? P coordinate was 15 minus 1, 25. So now, what's the task? The task is to determine a vector equation for line 2. Can't you get the vector equation of line 2 now quite easily? So one of them can be the position vector. And who is the direction vector of line 2? XB. XB can be taken as the direction of line 2. So get the direction of line 2. Direction of line is XP. So P minus XP is 15 minus 125 minus X is 115. This is 14 minus 2, 25 minus 5 is 20. Do you agree? 14 minus 2, 20. And it's actually, you can see XP is a direction vector, isn't it? So when you have a direction vector, if it's a multiple, since now this is not a coordinate, this is a direction vector. So you could take it in its simplest form. Can you see we have a multiple here? 14 minus 2, 20. So what's the direction vector in its simplest form? The simplest form is, because it's a direction vector. Remember, you can't do this for a coordinate. You can do it only for a direction vector. What is it? We can divide everyone by 2. 7 minus 1, 10. Okay. And then let's get the equation of line 2. So what is the equation of line 2? R equal A plus, give a different vector. Lambda was used for line 1. T was used for AX line. So we will use mu. So what is A? So what is A? For A, we could use 115 or we could use 15 minus 125. 115 plus mu times B is 7 minus 1, 10. Okay, so this is the equation of line 2. The equation of line 2. Is this clear? Okay, question number 8. They say the ellipse E has equation x square over 9 plus y square over 4 equals 1. Determine the eccentricity of E. So you can see here x square over a square plus y square over b square equals 1. In this ellipse, a is greater than b, which means the major axis is the x-axis. So that also needs to be considered when you are doing this, right? In your textbook, they teach you the equation, the ellipse equation, when the x is major and when the y is major. So here we are looking to the equation when x is major, right? So that is the equation, ellipse equation in the book they have given you when x is major. Basically, when a is greater than b, this is given to you. Okay, these are valid. So basically, the eccentricity is found by b square equal a square 1 minus e square. Can you see in the ellipse equation? This is the table from your F3 formula book. So b square equal a square 1 minus e square. So let's apply that. B square equal a square 1 minus e square. So you can see here x square over a square is 9, b square is 4. So b square is 4, a square is 9, 1 minus e square. Can you make e subject? 4 over 9 equal 1 minus e square. E square equals 1 minus 4 over 9. E square equals 5 over 9, right? Which is equals to root 5 over 9, which is root 5 over 3. So the eccentricity of the ellipse is root 5 over 3. Part B, hence for this ellipse, determine the coordinates of the foci. So what are the coordinates of the foci? The foci equation can you see plus or minus AE comma 0. Plus or minus AE comma 0. So we know the value of A is A square is 9, A is 3, E is root 5 over 3. This gives you the foci coordinates are plus or minus root 5 comma 0. Okay, and then the next part are the equations of the directrices. So the equations of the directrices equation is given to you as x equal plus or minus a over e. Can you see? X equal plus or minus a over e. Roman number 2. X equal plus or minus a over e. A is 3, right? A is 3. E is root 5 over 3, right? So x equals plus or minus, the 3 comes on top, you get 9 over root 5. Okay, x equal plus or minus 9 over root 5. Or else you could simplify it a little bit further, give the rationalized form 9 root 5 over 5. Is that okay? Okay, then we'll go to the next part. The point P lies on the ellipse and has coordinates 3 cos theta, 2 sin theta. The line L1 is the tangent to the ellipse at the point P. Okay. Using calculus, show that the equation for line 1 is 2x cos theta plus 3y sin theta equals 6. How do we do this? So if you draw a small visual diagram, what's going on here? You have your ellipse. And what's going on? They say the point P lies on the ellipse, right? The point P lies on the ellipse and has coordinates 3 cos theta, 2 sin theta. The line 1 is the tangent. So basically the line 1 is the tangent to the ellipse at the point P. Using calculus, show that the equation for line 1. Okay, how do we get the equation of line 1? What do we need to do? We have to get the gradient of line 1, right? How do we get the gradient of the tangent? How do we calculate the gradient of the tangent? dy by dx, right? dy by dx of the curve gives you the gradient of the tangent. So x square, when we differentiate with respect to x, this is 1 over 9 into x square differentiation is 2x plus 1 over 4. How do you differentiate y square? First priority for the power, you get 2 y to the power 1, and after you're done with the power, go inside and differentiate y. Y differentiation is dy by dx. The reason because we are differentiating with respect to x. Here to x square differentiation was 2x to the power 1 and x differentiation is 1. Here y square, you take 2 to the 2 from 2y to the power 1, and then y differentiation with respect to x is dy by dx. Equals on the other side, differentiation of 1 is 0. Let's simplify. This becomes 1 over 4 into 2 is half y. dy by dx equals the other one. 1 over 9 into 2x goes to the other side as a minus. Minus 2x over 9. dy by dx equals minus 4x over 9y. Do you agree? And now what do we do? Replace the replace the x and y. Minus 4x is 3 cos theta over 9 times y is 2 sine theta, because x and y is given to you as 3 cos theta comma 2 sine theta. Replace xy. How does it simplify? 2 times 2 and 4 cancels, right? 3 times 1, 3 times 3. This we get what? So over here I get minus 2 cos theta over 3 sine theta. Is that correct? The time to get the equation of the tangent then. Y minus y1 gradient x minus x1. Y minus y1 is the y coordinate, which is at the point P, right? 2 sine theta. Gradient is what we found. Minus 2 cos theta over 3 sine theta into x minus x1 is 3 cos theta. We need to get the show that. In the show that we have y multiplied, right? Y is not alone. So shall we take the sine theta to the other side? Multiply the 3 sine theta with the y and 2 sine theta. So we get y into 3 sine theta is 3y sine theta. Minus 3 into 2 is 6 sine square theta. Minus 2 cos theta into x is minus 2x cos theta. Minus 2 cos theta into minus 3 cos theta is plus 6 cos square theta. Do you agree with me? And then what I can see is there's a minus 6 sine square theta here. There's a plus 6 cos square theta here. I'll bring it over here. So I get 3y sine theta, and I'll bring the minus 2x cos theta here. Plus 2x cos theta equals 6 cos square theta plus 6 sine square theta. Can you see the pattern here? 6 can be taken out and you get cos square plus sine square, which is what? 1. Cos square plus sine square is 1. So 6 into 1 is 6. 3y sine theta plus 2x cos theta equals 6. Okay, so that's the show that 2x cos theta plus 3y sine theta equals 6. So 3 marks. This is the show that. Okay, is this clear? Okay, so they say the line 2 passes through the origin and is perpendicular to line 1. The line 1 intersects the line 2 at the point Q. Determine the coordinates of Q. Okay, so we found the equation of line 1. They say line 2 is perpendicular to line 1, right? So, if the lines are perpendicular, what's the gradient of line 2? Yeah, the gradient product is -1. So basically reciprocal of this of the gradient of the tangent, and change the sign, switch the sign. Negative becomes positive and you get 3 sine theta over 2 cos theta, right? So if we get the equation of line 2, y minus y1 equal gradient x minus x1. And then they say line 2 passes through the origin, which means the coordinate is 0, 0, right? Y minus y1 gradient. Gradient is 3 sine theta over 2 cos theta. X minus x1 is 0. Can you see? So the equation of line 2 is 3 sine theta over 2 cos theta into x. Okay, so then point Q is the place where the lines intersect, right? L1 and L2 intersect at the point Q. So to get point Q, what we do is we'll solve line 1 and line 2 simultaneously. So line 1 equation, we get 3y sine theta plus 2x cos theta equals 6, right? So coming back to our question, we were over here. So let's input the line 2 value. 3 times y is 3 sine theta over 2 cos theta into x plus 2x cos theta equals 6. So I end up getting here 9 over 4 sine theta over cos theta x plus 2x cos theta equals 6. Are you with me? Then we'll multiply the whole equation with cos theta. Or we'll multiply the whole equation with 4 cos theta, right? Because I want to make x a subject. So I end up getting here 9 sine theta times x plus 2 times 4, 8x cos square theta, right? I multiply with 4 cos theta. Plus 24 cos theta. Okay. Yeah, this is 9 over 2, right? Not 9 over 4. Yeah, sorry. Should be 9 over 2. If it's 9 over 2, I have to multiply with 2 cos theta. This is 9 over 2, not 9 over 4. 9 over 2 sine over cos. So we'll multiply everyone with 2 cos theta. When you multiply with 2 cos theta, 9 sine theta. Okay. Yeah, so this is 3y sine theta, right? I have, okay, let me do this. I have not, there's a slight error here. So I will change this because I have not input the sine theta value. So again, this is 3 into y is 3 sine theta over 2 cos theta x. And then there's this sine theta again here, right? And then plus 2x cos theta equals 6. So this gives me 9 over 4 sine square theta. 9 over 2. 9 over 2 sine square over 2 cos theta plus 2x cos theta equals to 6. So now I'll multiply the whole equation with 2 cos theta. And there's x here, right? Yeah. 9 over 2 sine square over cos theta. And there's this x here, right? And 2x cos theta equals 6. Yeah. Multiply the whole equation with 2 cos theta. So I get 9. Shall I write the x in front? 9x square sine square theta plus 4x cos theta equals 6 times 2, 12 cos theta. So now we can take x out. 9 sine square theta plus 4 cos theta. Cos square theta, yeah. Yeah, 2x cos theta into 2 cos theta is 4x cos square theta into c. Yeah. So then is there any way that we could simplify this a little bit further? Yeah, so you can see we have 4 cos square here and we have 9 sine square here. So how could we simplify this a little bit further? You know, sine square plus cos square is 1, right? So we could break this up as like, for example, because there's 4 cos square and here there's 9 sine square. You could break this up as 5 sine squares and 4 sine squares. Do you get me? Because we can input a part of this as 1. 4 sine square theta plus 4 cos square theta. Do you agree? 5 sine square plus 4 sine square is the 9 sine square. Okay? And then we get here x times 5 sine square. So here 4, you take the 4 out, right? 4 sine square plus cos square becomes 1. So 4 into 1 is 4. We end up getting here x equals 12 cos theta over 5 sine square theta plus 4. Is that okay? This is the x value. Now substitute this value into the y and get the y coordinate as well, the y coordinate of q. So even if you keep your answer for x as 12 cos theta over 9 sine square plus 4 cos square theta, at this point, even that is okay for the coordinate of q. So here I just went for a little bit of extra simplification. But if you kept your answer as 12 cos theta over 9 sine square plus 4 cos square, that is perfectly fine. Okay, then let's get the y value. So I will input that in the equation of line 2 because it's the easiest one to simplify. 3 sine theta over 2 cos theta times x. Let's input the x value. 3 sine theta over 2 cos theta times the x value. X is what we just found. 12 cos theta over 5 sine square theta plus 4. Do you agree? The cos theta cancels. 2 times 1, 2 times 6 is 12. So I end up getting here 6 times 3, 18 sine theta over 5 sine square theta plus 4. This is y. So basically, the coordinates of Q are going to be 12 cos theta over 5 sine square theta plus 4, 18 sine theta over 5 sine square theta plus 4. Is this okay? So these are my coordinates of Q. Okay, so some of you might can get different answers depending on whether you make x a subject as 12 cos theta over this 9 sine square plus 4 cos square. Okay, or there might be another person who could give the answer entirely instead of sine square. You could convert this cos square as 1 minus sine square, and then you get this. Or else another person could use sine square as 1 minus cos square and give the answer entirely in terms of cos. Okay. So all those answers are correct. Okay, then we'll move to the last part. In the last part, they say show that as theta varies, the point Q lies on the curve with equation x square plus y square square equal alpha x square plus beta y square, where alpha and beta are constants to be determined. Okay, so show that as theta varies, the point Q. Now already we got the coordinates of point Q, right? So they want you to find the Cartesian equation that point of point Q. So you have to show how point Q varies. As theta varies, how the point Q is moving. So you have to get the Cartesian equation of that point Q is following. Okay, how do we get that? How do we get that? So I think you saw we already got the point Q coordinate. The x coordinate of point Q. The x coordinate of point Q was 12 cos theta over 5 sine square theta plus 4, right? And the y coordinate is 18 sine theta over 5 sine square theta plus 4. Okay, your task is simple. Your task is to eliminate the theta. Your task is to eliminate the theta and get an equation connecting x and y. So that's your task. Okay, so get started on it. Okay, so to get now we need to get the expression for x square plus y square square equal alpha x square beta x square beta y square. You're supposed to find alpha and beta. So you know what the best thing here is? Let's use the x value and the y value to this side and get x square plus y square square and actually show that we get an expression in terms let's get this expression alpha x square plus beta y square. Okay, so we'll use the value. That's the easiest way to get it done. X square plus y square square, right? Who is x square now? 12 cos theta over 5 sin square theta plus 4. When you square it, it becomes 144 cos square theta over 5 sin square theta plus 4 whole thing square plus 18 sin theta. When you square it, what do we get? Can I know the square of 18? 324 sine square over 5 sine square theta plus 4 whole thing square. And then we square that whole thing, right? Because this is x square plus y square and the square of this entire term. Are you with me? Okay, then we'll try to get this done in the easiest way possible. We can see the denominator is the same for both, right? Both of them are having a common denominator, 5 sine square theta plus 4 to the power 2. So we get here 144 cos square plus 324 sine square. Oh, yeah, Kian Lahir, what's the problem? Yeah, Kian. Lahir, you can talk to me.
I think the recording is now, ma'am. I think it's recording now.
Okay, so that to show that as theta varies, the point Q lies on this curve with the equation. What I did was, so we took the x and y coordinates of point Q, right? The x and y coordinates of point Q, we already found it. So then I'm going to substitute that into this equation, x square plus y square square. You are supposed to show it's equal to alpha x square plus beta y square. So to get the alpha x square beta y square, we will replace the x with 12 cos theta over 5 sin square theta plus 4. And y with 18 sin theta over 5 sin square theta plus 4. So you can see that I have replaced that over here. Can you see x square plus y square square? So x square is 144 cos square over 5 sin square theta plus 4 whole thing square because we squared x plus y square is 18 sin square theta 18 sin theta over 5 sin square theta plus 4. I have squared it completely. That's what I got here as 324 sin square theta over 5 sin square theta plus 4 whole thing square. And then what we did was, this is a common denominator. 5 sin square theta plus 4 whole thing square is a common denominator. So then 144 cos square theta plus 324 sin square theta comes together. And then you can see that I'm trying to simplify this in the easiest way. So what I did was I used the cos square theta as what? I use the cos square theta as 1 minus sin square theta because I'm trying to simplify. Now you can see if you go to open this, there's a square in here and there's a square again outside the bracket. If you go to expand everything, it's going to be really large. Okay, so in that case, what I'm trying to do is I can see there is a sin square in the denominator. So if I can get my denominator also completely with sin square, I might have a chance of simplifying this in an easier manner. So I replace the cos square with 1 minus sin square and then we open the bracket with 144. 144 into 1 is 144 minus 144 sin square plus 324 sin square. That gives us plus 180 sin square. And then what I did here was we took the common thing out from 144 and 180. So first we took out a 12, but we could directly, if you look into here, we can take out directly a 36, right? We could skip this step and come over here. Directly taking out a 36, you get here 4 plus 5 sin square theta divided by 5 sin square theta plus 4 whole thing square. So this gives an opportunity to simplify this sum really easily because you can simplify the numerator and the denominator. You can cut out. So you end up getting 36 over 5 sin square theta plus 4 whole thing square. Okay, and then we end up getting 1296 over 5 sin square theta plus 4 whole thing square. Now that is the answer of what? That was the answer of x square plus y square whole thing square, right? This is equal to, you are supposed to show it's equal to alpha x square plus beta y square, where alpha and beta are values to be found. Okay, shall we input the values now? So x square plus y square whole thing square is 1296 over 5 sin square theta plus 4 whole thing square into alpha, who is x? So our x value was 12 cos theta over 4 plus 5 sin square. So x square gives me 144, right? Square the x value, 144 cos square over 4 plus 5 sin square theta whole thing square, because we have x square, so we have to square it. Are you with me? Alpha x square plus beta into y square. Who is our y? Our y was 18 sin theta over 4 plus 5 sin square theta. So when you square it, 18 square was 324 sin square theta over 4 plus 5 sin square theta. Whole thing square. Are you with me? So now what you need to do is you have to solve this equation and what? Get the value of alpha and beta. You have to get the values of alpha and beta. Okay, let's simplify. Okay, so after you come to this point, you can see the whole equation has the denominator 5 sin square theta plus 4 square as a common denominator. So you could multiply the whole equation with that, or simply it cancels out from everyone because you multiply the entire equation everyone by 4 plus 5 sin square theta whole thing square. So you end up getting here 1296 equals 144 alpha times cos square theta plus 324 beta times sine square theta. Can you see? Now your task is to get the value of alpha and the value of beta. So now you can see this over on this side I have cos square sine square. Over on this side I just have 1296. So what's the technique that we can use to get the alpha value here? Now you need to realize, now I need to get the alpha and beta value. Basically we need to do something like comparing coefficients here. But to compare the coefficients, like I have a cos square here, but I don't have any cos square here to compare. There's a sine square here and I don't have a sine square. But if I had, we could do comparing coefficients. So what we do here is, we take 1296 into 1 as sine square theta plus cos square theta. Is there any difference in what I'm doing here? No, right? Sine square theta plus cos square theta is basically a 1. So the reason why I input it there is because we need to create the sine square cos square coefficient on both sides. So we could do a comparing coefficient. So we could compare. And I get here 1296. I'm comparing for the cos square. Let's compare for the cos square first. So over on this side, I get 1296 cos square theta. Equals on the other side, what do I have? 144 alpha. How much is alpha? 1296 divided by 144 and alpha is 9. And when you compare coefficient for sine square theta, what do we get? 1296 sine square equal 324 beta. How much is beta? 1296 divided by 324 gives me beta is 4. So alpha value is 9, beta value is 4. So write the answer. X square plus y square square equals 9x square plus 4y square, because it's alpha x square plus beta y square. So they want to see that expression. Okay, they want to see this expression. So make sure you substitute the alpha beta values into this expression and write the answer. Okay, is this clear? Okay, so this is the end of the January 2022 F3 paper.